Swayam Prabha. Digital India. Educated India.
And welcome back everyone. We are learning the basics of building construction, and today we are going to start a new module on pointing and plastering. So far we have studied the other components of building construction, and we are gradually moving towards finishing our building. So now it's more about how to get the look that we want, particularly for our building. So we are going to first start with pointing, and then we will learn about different types of plastering. So what do we mean by pointing? The term pointing is referred to the finishing of mortar joints in masonry. In exposed masonry, joints are considered to be the weakest point. They are the most vulnerable spots from which rainwater can enter. So it's important for us to finish it in the proper manner so that we can protect our masonry walls. Pointing consists of raking the joints to a depth of about 10 to 20 mm and filling it up with better quality mortar in desired shape. This is the time in which we can actually provide a particular shape to these joints by adding the new mortar in different order or different shape or arrangement. Let's learn a little bit about the application process of pointing. Definitely, we are going to be using mortar for pointing, as already mentioned. So pointing can be done with the following types of mortar mixes. The first is a lime mortar, which is at a ratio of 1:2, that is 1 is lime, 2 is sand or surki. And we can also use cement mortar in 1:3 mix, so 1 cement and 3 sand. So for any new surface, all the joints are raked down. By raking we mean we actually have to clear out the joints of the reminiscence of the old mortar that was used to create the masonry walls. So this is raked down to a depth of about 20 mm while the mortar is still soft. Then they are cleaned and we thoroughly wet the wall surface. If we are dealing with an old wall, that is, we have an existing wall which has been there for quite some time, and then we want to do pointing on it. For that old surface, all the loose pointing and superfluous mortar on the surface and in the joints are removed. Then they are cleaned and thoroughly wetted. After preparing this surface, cleaning and wetting the joints, mortar is carefully placed in the desired shape in these joints. So the mortar is pressed using a small trowel to establish a perfect joint between the old mortar and the new mortar that we are adding in a particular shape on top of it. Now in case of first class bricks, the mortar does not cover the face edges because we have extremely sharp, clear edges in first class bricks. We do not need to hide its sides or faces. So we have to be careful that we do not cover the faces with the mortar that we are using, especially the new mortar that we are adding in a desired shape. This is particularly useful in the case of exposed brickwork. If we are using first class brickwork in exposed brickwork in our facade, we do not need to cover the faces. The pointed surface is kept wet till it sets. So we have given a desired shape to the pointing, so we will have to keep it wet till it sets. Now let's see what are the various types of pointing that we can do. The classification of pointing in this case has been done on the basis of the desired shape that we are giving to the new mortar that we are adding into the joints. So the first type is called flush pointing. Now as the name suggests, it is flush with the existing surface of the wall. So that means we are going to get a straight edge after this pointing is done. It is the most common type of pointing, and it is used to create a smooth and even surface on the mortar. The mortar is pressed flush with the face of the wall, but in this case it is not exactly very water resistant. It is best used when the wall is about to be covered with plaster and the joints have to be hidden under the paint. So if we want a wall look, which is a very common look in our buildings, where we have a flush surface on which plastering is done and then we have a smooth painted surface on top, in that case this type of pointing can be very useful because it gives a straight edge to us in the end. The second type is called recessed pointing. So as the name suggests, it is slightly recessed or moved backwards from the surface of the wall. So in the previous example, that is a flush pointing, we had a straight edge, but in this case we will have a slight recess. A type of mortar joint that is characterized by its depressed or recessed appearance is called a recessed pointing. The mortar is set back from the edges by at least 5 mm. We want to give it a bit of a recess so that we can see it when we look at the wall. So we want to give a recess of at least 5 mm. This type of pointing is created by pushing the mortar into the joint with a special tool which is called the recessing tool. Now this tool makes a rectangular groove in the mortar. As you can see, there is a rectangular groove which is created at least 5 mm in depth. Now the recessed pointing is used in buildings both residential and commercial, and it can be used on any type of masonry wall including brick, stone or even concrete blocks if we are using that for our masonry courses. But in this case the joints will be slightly visible. The third type of pointing is called rubbed or keyed or grooved pointing. It is a type of mortar joint that is pressed into the mortar with a pointed tool, which will leave a curved arc groove in the mortar. As evident in the figure, there will be a slight arc that is created. Hence the name keyed or grooved pointing. Now this gives the wall an excellent exterior look. So you will be able to see horizontal keyed grooves in the joints, which gives a very aesthetically pleasing facade. Now steel bars are often used to give a semicircular shape to the keyed pointing. This enhances the appearance of the wall. So this particular shape can be created with the help of steel bars. The cross section of the steel bar being circular or will be able to give us a semicircular shape to the keyed pointing. This provides a very strong and durable joint that is capable of withstanding extreme weather conditions. Unlike flush pointing, this is better suited for external walls. The next type of pointing is called beaded pointing. It's exactly opposite of the previous example. There we had a keyed groove, a semicircular groove inward, but in this case we are going to have a bead outward. This type of mortar joint is created by pressing mortar into a joint of brickwork, and that is rounded off with a beaded tool, which gives its distinct appearance. So this type of joint is not as water resistant as some of the other options, but it is considered to be more aesthetically pleasing as it helps us cast interesting shadows in the facade. So because we have created a bead which is a three-dimensional bead extending outward from the wall, we should be able to have very interesting patterns formed with the shadows on the facade. So based on aesthetic appearance, if that is the demand, then we may go for this type of pointing. The next type is called struck pointing. In this type, the bottom edge of the mortar joint is recessed, allowing the top of the next brick edge to project out slightly. So there will be a gap created by slightly recessing one side of the mortar joint to make the brick edge jut out. Now the face of the pointing is usually inclined and the upper edge is pressed back by 10 mm. Now this can also help create aesthetically pleasing shadows that enhance the masonry, gives it a distinct look. However, it is not very weather resistant as it allows water to sit on the top side of the brickwork. Tuck pointing is another type of pointing which is formed by pressing the mortar in the racked joint to flush it with the face. While the pressed mortar is fresh, grooves or narrow channels of about 5 mm width and 3 mm depth are made in the center of the groove. White cement putty is then used to fill up this groove, tucked in with white cement putty, and that is left projecting beyond the face of the joint by at least 3 mm. So what we do is, this is the old mortar. On front of it, we are adding the new mortar. In this mortar, we create a groove first. This groove is about 5 mm by 3 mm. Within this groove, we then add white cement putty and we create this notch. This will be jutting out at least 3 mm from the surface of this joint. That is known as tuck pointing. So what we are doing is we are tucking cement putty into the groove created in the pointing mortar. Now V-pointing, very self-explanatory. As the name suggests, we are going to create a V-shaped groove in the joints of the brick walls. This process is used to repair damaged brickwork joints, as it can help to improve the overall appearance. Now the V-grooved pointing can also be used to prevent water infiltration, as the V-shaped groove helps to direct water away from the wall. So if water comes in, it is directed away from the wall due to this distinctive V-groove that we have created in the pointing mortar. Weathered pointing is kind of the exact opposite of what we did in the V-shaped pointing. In this type, the mortar joint is created by pressing mortar into the joint of brickwork on an angle sloping downwards from the brick above. So this type of joint is also very aesthetically pleasing, and it is quite common in older style building, as it can help to give the impression of age and character. So that may be the aesthetic choice that we make, but in this case what we are doing is we are creating a V-shaped groove, but in the opposite direction. We are making the mortar jut out. So this too will be creating very interesting shadows on our facade, as it is projecting outward from the face of the wall. So those were the various types of pointing that we can use in our building based on the aesthetic look that we are trying to achieve, or the demands of the location, the construction type, the type of building. We can go for one of the types of pointing. But the basic idea is we have to press the older mortar into the joint, rake the joints, clean it, then add new mortar which is going to be used for pointing, give that mortar a distinctive shape based on the type of pointing that we have selected, and then allow it to set. So that is basically pointing, and it is usually done to prep the building before we move on to the next stage of plastering. So let's now take a look at what do we mean by plastering and what are the other terminologies we need to learn that are associated with it. So plastering is the process of covering rough surfaces of walls, columns, ceilings and other building components with a very thin coat of plastic mortar. So this thin coat of plastic mortar allows us to create a smooth, durable surface. The coating of plaster material or mortar is termed as plaster, and plastering on external exposed surfaces, that is outside walls, is known as rendering. So why do we need to go for plastering? Plastering is done to protect the external surfaces against penetration of rainwater and other atmospheric agents. It gives a smooth surface on which dust and dirt cannot lodge. It may also be used for a decorative effect. It protects the surfaces against vermin, and it may also be used to conceal inferior materials that have been used in construction, or if defective workmanship has been done. So this is the opportunity for us to correct our previous mistakes. Is there any part of the building component that needs to be hidden or has to be given a very smooth new exterior look? We may go for plastering. Now, to use any material for plastering, there are certain characteristics that it should inherently have that makes it a good plaster. So first of all, it should adhere to the background or stick to the background, and it should be able to do so despite the variations in seasons and other atmospheric conditions. So we cannot use a material which alters itself throughout the seasons, or when there are extreme atmospheric condition, it deteriorates. So we want to pick a material which is suitable for all weather conditions, especially if we are using it in exterior surfaces. It should be hard and durable because it's going to last for many years. We may be able to paint our surfaces multiple times, but we wouldn't want to go through the process of plastering again and again. So we do not want a material which is not durable. It should also possess good workability so that we can easily apply it on rough surfaces of the wall and create smooth finishes. It should be possible to apply this material in all weather conditions, because we can obviously not schedule our construction projects based on what weather we need to do the plastering. It should be cheap or affordable, and it should also be effectively checking the penetration of moisture, because this is the material that is going to create a sheath over our masonry walls and protect our masonry walls from damping. In fact, nowadays there are many materials which are available in the market that improve the waterproofing qualities of the masonry wall. So much of this is done in a cosmetic manner by using proper good quality plastering materials. Now let's see what are the different types of plaster and how we can select them as per the requirements of our construction project. To select a suitable type of plaster, we have to take a look at some of the conditions. The first is availability of binding materials, the durability requirements. So where are we using this plaster, what type of building it is, how long we would like it to last. So according to that, we have to select the material. The finishing requirements, do we need a textured finish, do we need a smooth finish? That will also determine what type of material we are using for plaster. We have to see the climate of our location as well. What are the atmospheric conditions and variations in weather that our building will undergo. We also have to see the location of the surface, whether it is exposed or interior. Maybe it has some exposure to water as well. So we have to take a look at the location in the building where we are applying this type of plaster and accordingly select our material. Mainly, there are three types of plastering materials that we use. The first is we can have lime mortar plaster. The second is we may have a cement mortar plaster, or we may go for a combination of both, that is a mixture of cement and lime mortar for our plaster. Now let's take a look at all of these one at a time. So let's start with lime mortar. In this case, we can use both fat lime as well as hydraulic lime. Now both of these have distinct characteristics that make it suitable for different purposes. We will take a look at the difference between fat lime and hydraulic lime as well. Now fat lime is preferred since it yields good putty after slaking. So the process of slaking is done. After that, fat lime is going to yield good putty, so we might prefer this. In case of hydraulic lime, it contains certain particles which slake very slowly due to atmospheric exposure, which gives rise to blisters. If unslaked particles stay in such a plaster, blisters continue forming during the slow slaking process, damaging the plastered surface. So we do not want unslaked particles to remain in the plaster. But hydraulic lime actually ends up giving us a harder and stronger surface. So while opting for hydraulic lime, it should be ground dry with sand. The lime sand mix proportion can either be 1:3 or 1:4 if we are going for fat lime. But if you are going for hydraulic lime, we can use a ratio of 1:2 between lime and sand. So what is the difference between fat lime and hydraulic lime? Fat lime is also called non-hydraulic lime and it is composed of calcium oxide, whereas hydraulic lime is made from impure limestones containing clay and other materials. In case of fat lime, it is made by heating pure limestone in a kiln and does not possess any hydraulic properties. So there are no hydraulic properties, etc. So it doesn't sit or harden when exposed to water alone. It has a slow setting time, carbonation process, and low strength. It's ideal for repointing old masonry structures. In case of hydraulic lime, it has inherent hydraulic properties, allowing it to set and harden even under water. This is due to silicates and aluminates produced during the burning process. This sets and gains strength very easily, and it is suitable for construction in damp environments such as basements and foundations. Because of its distinctive hydraulic property, it is able to set under water, so it's very useful if we are constructing a part of the building which is exposed to water. So this is the basic difference between fat lime and hydraulic lime, which tells us that the application of fat lime is more in areas which are old masonry structures, or maybe they are not exposed to that much of water, whereas in hydraulic lime we may want to go for it in situations where there is more water. This also gains strength quickly, so that should make it easier for us to construct basements and foundations. The next type of material that we can use for our plastering is cement mortar. Now, because of its non-absorbent property, it is considered as the best mortar for external plastering and probably the most commonly occurring example in our today's construction. This is preferred over lime plaster in case of damp rooms like bathrooms and also in areas where damp climatic conditions prevail. It is stronger than lime mortar, most definitely. That the cement sand mix proportion varies between 1:4 to 1:6. The sand used for plastering should be coarse and clean, so it has to be prepped before we use it to mix the plaster. After water is mixed, the mortar should be used within 30 minutes of mixing to avoid setting of the mortar mix. So that is our time limit. Lime cement mortar has properties of both the previous examples because it's a mixed element where we are taking both lime and cement and mixing it with sand. So the addition of lime actually imparts plasticity and it gives a smooth surface finish. So it will have a smoother finish than the previous example of cement mortar plaster. Now mix proportions can be 1:1:6 between cement, lime and sand, or 1:1:8 or 1:2:8. Usually in this case we go for fat lime. So when we are creating lime cement mortar, we select fat lime over hydraulic lime. So those were the types of mortars that we can use to do our plastering. Now let's learn some common terminologies associated with plastering. Background. This is the surface to which the first coat of plaster is applied. So it is probably our finished pointed wall. Blistering. This is the development of local swellings on the finished plaster surface due to residual unslaked lime modules. So we had already learned that if we have some unslaked lime particles, in that case blistering may form on the finished surface. Cracking. This is the development of one or more fissures. So these are deeper cracks in the plaster due to movement in the background or the surrounding structure. So I'm sure all of us have seen fissures or cracks in our plaster. So this is called cracking. The next term, crazing, is the development of hairline cracks. Slightly different from the previous case. Cracking is deeper fissures, but crazing is just the development of hairline cracks. Usually they form in irregular pattern on the finished surface. They are very fine cracks and they do not extend to the whole width of the plaster. They are just surface hairline cracks. Dado is the lower part of the plastered wall where special treatment is done to make it better resistant. So based on the location of our building or the aesthetic look that we are going for, we may use different types of material in the dado portion, or we may also go for ornamentation. Dots. These are small projections of plaster laid on the background for fixing of screeds. Now screeds are straight edge in concrete work. So we make small projections of plaster which helps us guide the fixing of screeds. Hacking is the process of roughening the background to provide suitable bond or key for plastering. Just to remind you, background is the surface on which the first coat of plaster will be placed. So to make sure that our plastering really sticks well or adheres well to the surface, we might want to roughen it up a bit, and that process is called hacking. Keys are openings or indentations or corrugations on the background surface or undercoat to which the plaster will form a mechanical bond. Latence is the process when fine particles form on the surface of fresh concrete due to the presence of excess water. So if during the mixing of our fresh concrete there was excess water in it, it is possible that fine particles will form on the surface after setting. So that is called latence. Peeling is the dislodgement of plasterwork from the background. Another very common observation, especially in older buildings where we have chunks of plaster peeling off from the surface of the wall. Undercoats are coats of plaster applied under the finishing coat. Dubbing coat. This is the process of filling up hollow spaces in the solid background before applying the main body of the plaster. So there might be some irregularities on the background surface, there might be some patterns, there might be some hollow spaces. So we would like to fill that up before applying the main body of plaster because we want a smoother finish. So that is called dubbing coat. The finishing coat is the final coat of the plaster, also known as setting or skimming coat. So this is what will give our wall the finished look. So we want a smooth finish in the end, and that is the final finishing coat of plaster. So it must have become clear till now that we are using multiple coats of plaster on a particular wall. Flaking is the process of scaling away patches of plaster of previous coat due to lack of adhesion with the undercoat. So if it is possible that we have a wall and there are certain portions of the plaster that have not adhered well with the undercoat, we can take them away, and that process is called flaking. Gauging is the process of properly mixing various constituents of the plaster in correct proportion. Grinning is when mortar joints are clearly visible on a plastered surface. So if we are able to see the plaster joints, that is, we haven't been able to create a very smooth finished surface and the joints are still visible, that is called grinning. Grounds are wooden strips which are fixed to the background to which primarily finishing may be secured. So we have learnt the different terms which are associated with plastering, some of which are associated with the defects which are commonly occurring in plastering. Of course, towards the end of this lecture, we will study those defects further in detail. But before we get to that, let's learn about the different types of tools that we use when plastering our buildings. The first tool that we commonly use is called a gauging trowel. It is used for gauging small quantities of materials and applying mortar to moldings or corners. So this is what a gauging tool looks like. If it has a pointed edge, that is a sharp pointed edge in the end, that is known as a pointed gauging tool. And if we have a slightly chamfered end or a curved end, we call it bull-nosed gauging tool. So the main purpose is it allows us to take small quantities of different materials, mix it together. We have already learned that there are cement or lime or sand, other materials which are mixed together to create the mortar needed for our plaster. So gauging trowel will help us with that. And it will also help us apply mortars especially to the corners or edges where we need something pointed to reach. Floats are used for applying or spreading mortar on the surface. So this is what floats look like. We may have wooden floats which used to be more commonly applicable in older constructions. This is also called a skimming float. So even now if we need to provide the final finish to the wall, the top coat or the finishing coat, also known as the skimming coat, we can use the wooden float to give it that smooth finish. The metal float is more of a laying float. So the first time when we are laying the plaster and spreading it over the surface or spreading the coat over the surface, that is most useful in that case. The metal float is useful for laying, whereas the wooden float is useful in case of skimming or finishing of the final coat of plaster. Floating rule is used for leveling the plastered surface. So when we are using the metal or the wooden float to lay or finish our plastered surface, we should ensure that it is at proper level and we are maintaining the level throughout the surface of the wall. So for that, floating rule, which looks kind of like this. So it's like a wooden structure, looks similar to a scale or a ruler. So this floating rule helps us to maintain level throughout the surface when we are laying a coat of plaster. Now there are other miscellaneous tools like plumb bob, spirit level, set square scratchers, etc. that are used. The plumb bob is also called a plummet. So it is a pointed tip. Now this pointed tip, as you can see in the photograph here, can be made up of stone or wood or metal, and it is usually suspended from a string. So it kind of looks like a pendulum. It is suspended from a string, and this is used as a vertical reference line, also called the plumb line. So every time we need to create a vertical reference line while laying our plaster, so we can use the plumb bob. The spirit level, which is also called the bubble level, is an instrument used to determine whether a surface is perfectly horizontal or vertical. So the spirit level has a small bubble within it, and if the bubble rests exactly within the scaled or marked point, we can ensure that the surface is perfectly horizontal or perfectly vertical. So we are checking whether the level is maintained. So if there is a slope in the wall, or we have incorrectly placed our plaster and we've created a slope, the spirit level bubble will not rest in the marked point, and we will know that our surface is not leveled properly. So plumb bob and spirit levels help us maintain reference lines and levels while laying the different coats of plaster and finishing our surface. Slight mistakes in this might actually end up creating problems for us later on, especially if we are trying to fix fittings and fixtures onto the finished wall. If there is a mistake in the leveling, it might be difficult for us to fix such fittings onto the wall. We will realize that they are not fitting anymore because the surface is not leveled. Now, how do we determine how many number of plaster coats do we need for a wall? Now, this will depend on many factors. What type of masonry are we using? So, the wall construction, we've learned masonry, so we know that we can have random rubble masonry, coarse rubble masonry, brick masonry, cement block work, etc. So, we may use 1 or 2 or 3 coats of plaster depending upon the type of wall construction that we are dealing with. Now, 1 coat is used mainly for inferior work, as it causes heavy shrinkage and it also cracks later on. So, we've learnt what is cracking. Cracking is the formation of fissures or large, thick, deep cracks on our plaster. So, if we provide only 1 coat of plaster, which is generally done in inferior works, there will be shrinkage and formation of cracks. While applying for lime plaster, so if you are using lime mortar for plastering, usually 3 coats should be applied. But if we are dealing with cement mortar plaster, generally 2 coats is applied. Here, there's a list of number of coats needed for different types of backgrounds. So, what is the background that we've created? What type of masonry we've used to make that background? Again, reminding you, background is the surface on which the first coat of plaster will be placed. So, if we have a background of stonework, we should go for at least 3 or 2 coats. So, 3 if you are dealing with lime plaster, 2 if you are dealing with cement plaster. If we have a brickwork, very common, the most common type of masonry wall we are going to deal with, or we have a hollow clay tile, we may go for 3 or 2 or 1, depending upon the quality of work we are doing, depending on whether it's an exposed wall or an interior wall, we can select. If we can go for an inferior work, 1 coat of plaster may be selected, but it may lead to cracking in the future. If we are doing concrete cast in situ wall and we are creating that as a background, 2 or 1 coat is sufficient, because we already have a concrete cast in situ finish in the background. So, it should not deal with a lot of weathering. So, we should be able to accommodate that within 1 or 2 coats of plaster. If you are using building blocks, 3 or 2 or 1 can be used. If we have a wooden or metal lath, 3 coats are necessary, especially because metal can go through corrosion very easily if exposed to water. Wood too will be damaged if we used or expose it to water. So, we don't want these walls to be deteriorating when exposed to weathered conditions. So, we might go for 3 coats of plaster. If we have a fiber building board, 2 or 1 is sufficient. Wood wool slabs, again 3 or 2 coats needed, and cork slabs, 2 or 1 coats of plaster are sufficient. Now, let's see what is the application process in plastering. So, first of all, we have to prepare the background. So, if you are dealing with new surfaces, masonry joints should be raked to a depth of 10 mm in brick masonry and 15 mm in stone masonry. So, raking of the joints essentially means that we are scraping away any excess mortar which are there on the edge of the faces and creating space or keys for us to be able to apply the plaster coat. Stiff wire brush is used to remove any or all mortar droppings, any form of dust or latents which may occur. So, reminding you what is latents. Latents is particles which form on freshly laid concrete if the concrete has excess of water in it during the mixing. So, if any of that droppings, dust or latents occurs on the surface, we first want to clear that away before we start working on the plaster. So, we use a stiff wire brush to do the same. Unevenness in the surface, if any, should be levelled. To provide optimum suction, the surface should be washed with clean water and it should be kept damp uniformly. If we are dealing with old surfaces for plastering, we should avoid any dirt or scales. If there is any oil, paint or any other old loose crumbling plaster layers from the previous plaster, we would like to remove that before we start working. Now, let's see, we are dealing with lime plaster. How do we apply that? Usually, we take up 2 or 3 coats. Different coats have different names. The first one is called the rendering coat. This is the one which will be in contact with the background. Then we have the floating coat, which is in between. That's the filling of the sandwich. And we have the finishing coat or the skimming coat. The first coat is known as rendering coat, and the first coat the mortar is applied and pressed well into the joints and over the surface. Now, the surface should be kept at least 7 days, cured. We can damp it and then allow it to dry completely. A thickness of 12 mm is usually preferred. So, if the rendering coat, at least 12 mm should be kept as the thickness. The second coat, also known as the floating coat, here patches 15 cm cross 15 cm or strips 10 centimeter wide are made at equal spacing to act as gauges. This will help us guide the positioning of the screeds. Using a trowel, the mortar is then thrown and spread and rubbed on the surface with the help of a wooden float. It is cured to set completely for at least 10 days. In the previous case, we had given 7 days. Now we are giving 10 days to allow the floating coat of plaster to completely dry. The thickness is 6 to 9 mm. So, in case of the previous one, the rendering coat, we had 12 mm. Now for the floating coat, we are adding 6 to 9 mm. The third coat, also known as the setting coat or the finishing coat. A finishing coat of cream of lime is applied with a steel trowel and rubbed for a smooth finish. The rubbing is continued till drying happens. So the finishing coat is left for just a day and then cured for at least 7 days. So this is going to be a much thinner layer. So the first coat we had given 7 days for curing, followed by the floating coat which had about 10 days of curing, and then in this case we will have to allow it to rest for 1 day and then cure it for another 7 days. So those are the total number of days we are dealing with. So that was lime plaster. So let's see what happens if we are applying cement plaster. Cement plaster is usually applied in 2 coats. We have already learnt that. Now, although it can be applied in 1 or 3 coats as well, depending upon the purpose or application location. So, for a 2-coat plaster, the background is first prepared by cleaning the surface, raking the joint to a depth of 20 mm and watering it. A preliminary coat is applied if the surface to be plastered is very uneven or if it has a lot of holes. The first coat or rendering coat should have a thickness equal to the specified thickness of plaster minus 2 or 3 mm. So, let's say if we want x mm as the thickness of my plaster, minus 2 or 3 mm will give me how much should be the thickness of the rendering coat. So, this is the first coat that we've applied. Now, before applying the final coat, the rendering coat is damped evenly. A bit of damping is done. Then we apply the final coat, which may vary 2 to 3 mm in thickness. So, this is exactly why we had taken x minus 2 or 3 mm as the thickness of the rendering coat, because we know that when we apply the finishing coat, which is of course 2 or 3 mm in thickness, we will have the final finished thickness of plaster that we are aiming for in our construction. So, that was the application of cement mortar plaster. Now, let's quickly run through different types of plastered finishes. The first type is called a smooth cast finish. Smooth level surface is obtained in this case. The mortar is applied with the help of a wooden float. The cement and sand mix may be prepared at the ratio of 1:3. So, that is the first type, smooth cast finish. The next one is sand faced finish. It can be obtained by plastering in 2 coats. The first coat is applied in 1:4 cement sand mortar ratio for 12 mm thickness. This is the first coat or the rendering coat in zigzag lines. After a week, a second coat of mixture 1:1 is applied on 8 mm thickness. So, this is a smoother finish. The previous one is done in a zigzag format. So, 12 mm, 8 mm, 20 mm thickness. Finally, we are getting at the sand faced finish. The rough cast or splatter dash finish. The mortar for the final coat contains fine sand as well as coarse aggregate in the ratio of 1:1.5:3. So, the ratio between cement, sand and aggregate is 1:1.5:3. The pebble dash or dry dash finish is done by applying cement sand mix of 12 mm thickness, clean pebbles which are 10 mm to 20 mm in size, are dashed on the surface. So when the plastering is done, we will be able to see these pebbles throughout the surface of the finish. So that is why the name pebble dash is used to note this. The debitor finish is similar to the pebble dash, the only difference being the gravel or flint are hand pressed on the wet cement mortar surface. Scraped finish is after applying the final coat of 6 to 12 mm thickness. It is allowed to sit for a few hours and then 3 mm thick surface is scraped in patterns. So this will have a bit of a pattern or texture on the surface. The textured finish is used with stucco plastering. So if we have created the finished surface with a particular texture, it will be referred to as the textured finish of plaster. So those were the various types of plaster finishes that we can apply. Sometimes we have to do it in both the layers, both the coats. We may also go for certain types in which only the final coat is altered to give it a distinctive look. Now let's take a look at some of the common defects that occur in plastering. The first is called blistering. It is the formation of small patches of plaster swelling on the plastered surface due to lack of slaking of lime particles. Cracking is the formation of cracks or fissures in the plaster work. Crazing is the formation of hairline cracks on the surface. We have of course been introduced to all three of these in the terminologies. Efflorescence is the appearance of whitish crystalline surface. So if white crystalline substance is appearing on the final surface, this is happening due to the presence of salts which may be there in the plastering materials. So that is called efflorescence. Flaking is the formation of very loose mass of plastered surface. This is happening due to the poor bond between the successive coats. Peeling is the complete dislocation on some portion of the plastered surface. So if a part of the plastered surface peels off completely, we call it peeling. Popping is the formation of conical hole in the plastered surface due to expansion of particles post setting. Rust stains may also form. This is usually happening when the plaster is applied on metal laths. This is also why it is very important for us to go for at least 3 coats of plaster when we are dealing with metal laths. We may also end up with uneven surfaces if we are dealing with poor workmanship. This is exactly why it is very important for us to level the surfaces or coats properly. For this, we may also use spirit levels to check that our levels are okay, and that finally we use the floats to create a smooth finish. Otherwise, we will end up with uneven surfaces. Eventually, if we paint on top of uneven surfaces, especially under light or illumination, we will be able to see the waves that are created in the plaster. So you might observe this even in your residences, where you see that if the plastering has not been done in an even way, under the light, you can actually see those layers or waves in the wall. So that was all we had to learn about pointing and plastering. But before we end today's lecture, let's take a quick recap. So first we had learnt about pointing. What were the various types of pointing? Let's take a look again. This is of course based on the shape, the final shape that we are getting after finishing the pointing. So flush pointing, that was a smooth surface. Tuck pointing, V pointing has a V groove. Weathered pointing, beaded pointing, in which you have a bead projecting out, struck pointing, recessed pointing, and rubbed, keyed or grooved pointing. So these were the various types of pointing that we had learnt. In terms of plaster finishes, of course we can use 3 types of materials: lime mortar plaster, cement mortar plaster, or a mixture of lime and cement mortar plaster. But of course we can give it different types of finishes. We may use 1, 2 or 3 coats of plaster. If we are dealing with 3 coats in lime mortar, we will call it the rendering coat. The first coat will be called the rendering coat. the second will be the floating coat, and the last will be the skimming or the finishing coat. And based on the final look that we are getting on the last coat, we can call it smooth cast finish, sand faced finish, rough cast or splatter dash finish, pebble dash finish, deputer finish, scraped finish, or textured finish, as in case of stucco plastering. So that was all we had to learn about pointing and plastering today. With that, we end the 8th module of our basics of building construction. These are some of the books you may refer to further study this in detail. So far we have been learning about the other components of building construction, and we are gradually moving towards the finishing aspect of our buildings. So the first aspect that we studied today was pointing and plastering, and in the next lecture we will learn about painting, which will give our building the final look that we are aiming for. So thank you for joining me. See you soon in the next lecture.